Okay, so this time we'll be evaluating the validity of an argument using the truth table. We'll use an example to illustrate this. So first, let's try to define an argument. An argument consists of two things: a set of premises, P1, P2 up to Pn, so n premises, and a conclusion. So we have an argument, premises, and conclusion. Now, how do you know if an argument is valid? An argument is valid if the implication formed by the conjunction of the premises and the conclusion results to a tautology, meaning you make a conjunction of the premises and then you form an implication. So if premises, then conclusion. If you have a tautology, then you have a valid argument. So conjunction meaning and. So when you make a conjunction of the premises, then you have P sub 1 or premise 1 and premise 2 until premise sub n. Okay, so that's what you mean by conjunction of the premises. So let's say let P be the conjunction of the premises. So let P be P sub 1 and P sub 2 and until P sub n. So the implication of the premises and the conclusion would be if P, then Q, or P implies Q. So double arrow siya because it's an implication, not just a conditional statement. So again, a tautology is a statement that is always true, or is an argument that is always true, meaning the truth value, you don't get a false in the truth value, in the truth table. Okay, so let's have an example. All lawyers study logic. Non-lawyers do not love to argue. Therefore, those who love to argue study logic. Okay, so let's look at it this way. The first step that we need to do, the first thing that we need to do is to define our argument. Okay, so let's break down our argument. Let's define our variables. Okay, so let's say L be a person, is a lawyer. Let S be a person studies logic. Let's say another variable A be a person loves to argue. Okay, so if you look at this, we only have 3 statements. And we have to recall that that a universal statement can be equivalent to an implication, to a conditional statement. All P is Q is just equivalent to if P, then Q. So all lawyers study logic. If a person is a lawyer, then the person studies logic. If a person is a non-lawyer, then the person does not love to argue. Therefore, if a person loves to argue, then the person studies logic. Okay. So this is what we'll evaluate. Okay. So let's see. Let's convert this to logical statements. So if a person is a lawyer, then he studies logic. If a person is not a lawyer, then he does not love to argue. Therefore, if a person loves to argue, then he studies logic. So that's how we convert the given example into logical statements. Okay, so the next thing that we have to do is to evaluate this. Okay, so let's convert this to symbolic logic first. Well, those are the symbols above. So we have L. If L, then S. If not L, then not A. Therefore, if A, then S. Okay, then let's convert this into an implication. So we have if L, then S, and if not L, then not A, then, or implies, if A, then S. So next, finally we will be able to construct our truth table for this argument. Okay, so again, remember we have three statements, A, S, and L, right? And each of the statement has two possibilities. Each can be either true or false. So each statement you have two possibilities and three statements. And we have three statements, so we have 2 raised to 3, which is equal to 8 possibilities. So our truth table will have 8 rows. Okay, so how do we do that? We just try all the possibilities, all the possible pairings, all the possibilities for true or false. Since there are 3, so we have this. If you study the table very carefully, the first 4 rows has the value for L that is true, and then you're checking all the possibilities for the truth values of S and A. So if L is true, then S can be true and A can be true. S can be true, A can be false. S can be false, A can be true, or both can be false. So the same thing if L is false. So you just do that. Take all the possible truth values. Okay, now let's take the truth values of if L then S. So conditional statements, it's only false when we have if true then false. So let's look at the columns that are shaded in green. So the only false statement is the one that has if true then false. All the rest is true. That's a conditional statement for you. Now let's look at not L and not A. For not L, you just have to negate all the values of L. So look at the L column, just negate it. Just take all the negation. Kung positive, negative. If negative, it becomes positive. So the same with not A. Okay? And then we'll take if not L, then not A. Again, this is a conditional statement of the columns that are shaded in blue. Again, this will only be false when we have an if true, then false. Okay, so you see that? Okay. Next we have if A, then S. That's the conclusion, right? So if A, then S. So if A, then S. Look at the column for A, then S. So conditional statement, only false when we have if true, then false. Okay. Now, next is we take the conjunction of the premises. So our premises are if L then S and if not L then A. So we let the first one be B and the second one be D. So we have a conjunction of B and D. And if you have a conjunction, a statement, an AND statement, it is true only when both statements are true. False false if otherwise. So that's it. Then the implication would be if B and D imply C, or if B and D then C. So our C is the conclusion, the if A then S. You see that? Now, if you observe the truth table, we have a tautology. Don't you see? The implication has true values for all of its rows, meaning that it's a tautology. If it's a tautology, then the argument is valid. Okay, so that's how you use the truth table to determine the validity of your argument. Now let's verify this using the Euler diagram. Okay, so for the Euler diagram, the first statement says all lawyers study logic. So the set containing lawyers is inside the set containing the people who study logic. Now, that's very easy. Now the second one is quite tricky. It says non-lawyers do not love to argue. Meaning if a person is not a lawyer, then the person does not love to argue. And let's try to avoid having negative statements. So let's try to take the contrapositive of these statements, which is we negate A then the negative of L. So if A, then L. That's the contrapositive. So a person who loves to argue is a lawyer, or all who loves to argue are lawyers. So it's inside the set for lawyers. So therefore, if we look at this, a person who loves to argue studies logic, because the set for all persons who love to argue is inside the set for all persons who study logic. Hence, the argument is valid. Again, what is the conclusion in the argument? If a person loves to argue, then he studies logic. So, here it is.